I imagine that all of you are excited to get started learning Java. It is a great programming language for new programmers, for those learning the basics of developing their own software applications. We're going to learn a lot. We'll go through a lot of concepts, but we will be starting slow and working our way up. It takes a 2-semester course to get through all of the materials, so you'll have a great opportunity to learn a lot of things and practice along the way. Many students wonder when they start a course like this, what is expected that they know already coming into the class. My only anticipation is that you understand the basic ideas and language surrounding developing or coding your own programs. It's important to note that all computers are only useful if they have software on them, and all software is written through source code or programming languages in order to communicate with the hardware of the computer. As I said, Java is a simple and easy to learn language, so it is good for beginning programmers. If at any time you're going through the class and you find that a concept is challenging for you, or I use terminology that you haven't heard before, or you just feel like you're not getting the full concept, please reach out to me. You can use the Canvas messaging system or my direct email address that's available inside the syllabus. I look forward to working with everyone this entire semester, and I encourage you to stay active and follow through the material. So I'd like to begin our process of learning Java by creating a very simple program. I will be using a tool called Notepad++ to do all of the examples in this class. There are a number of other useful tools out there that you may have heard about from friends or on the internet. I'm comfortable with you using whatever tools you would like. However, I do encourage you to not get so caught up in learning tools that you fall behind in learning the programming. Notepad++ is robust enough for the needs of this class and simple enough that its features won't get in the way of focusing just on the Java. All programs are generally created in what we call a text editor, or IDE, Interactive Development Environment. These will create a plain text file that holds the source code in the language you've worked in. These files then go through a process of being compiled, which we'll talk about in a little bit, to be turned into the binary format that allows it to be run by the computer and produce the results you're looking for. The file we create is known as the source code. Throughout this course, the source code is what you will be turning in for your assignments and exams, so that I can look at those, see how you did, compile the work, and so on and so forth. So in Java, all source code files will define something called a class. Every class will be compiled into the program and used to produce the results you're looking for. We're going to save a lot of talking about exactly what a class is for the second half of this course, after the midterm. For now, just know that you will be starting all of your programs with public class and then a user-defined or programmer-defined name. In this particular tool, if I go to language and select the language we're writing in, I get a special color coding that can be helpful when I'm working in Java. Knowing that specific elements within the program are colored in specific ways helps me know if I've made any mistakes or not. So I will be turning that on in all of the examples that I do. In general, everything inside of a Java class file or program begins with what we call a header, which is just a series of elements that we'll talk about in more detail throughout the class, followed by a block. The block will be begun with an opening curly bracket and completed with a closed curly bracket. Any code that appears between those two curly brackets are part of that code block. So we'll see many different kinds of Java coding pieces, like a class, and they will have some code followed by the open curly brackets and code inside of that and the closed curly bracket. For now, I just want to give you a simple introductory look at the elements that we will be using. This first element is called an access modifier. We'll be using those a little bit this semester and expanding on that in the advanced class next semester. As I said, every file that you write code in will be a class, so we identify it as such, and then we provide a name for that class. The name will generally be one that sort of gives the person looking at your code or yourself an idea of what it does. Something that is part of a tradition in programming languages is that we call the first or simplest program Hello World, which is a program that only prints a simple message to the screen. It allows us to get comfortable with the bare bones of what's necessary to create a functioning program in the language, and does simple output. That's where we're going to start with in this example, and it will be the beginning point upon which we build everything from this point forward in the class. As I said, the curly brackets indicate the beginning and the end of the block. In this case, the block is the definition of the class. So in this, again, in the simplest version of a program in Java, the next thing we're going to need is a piece of code called a method. We will be learning a lot more about methods throughout this class this semester, as well as expanding upon that in the advanced class. The normal or base method that all runnable programs will have is a main method. We define that in this way: public static void main string args. Again, this is a header which will be followed by the opening and closing curly brackets, where the definition of this code block will be entered. Let's unpack just a little bit and briefly the elements that are in this header. We again have our access modifier, public. We have another modifier that will be discussed in great detail near the end of this semester, static. The keyword void indicates that there will be nothing sent back from this method. Once the code that runs inside the block is completed, the program will be done and there will be no additional output. Main, much like hello above, is the name of this method. For all intents and purposes, this is a user-defined identifier for the block. However, in the Java programming environment, it will expect you to have this main method, this method called main. It will be looking for that as the place to start when you run your program. The method always will have, or any method will always have, these opening and closing parentheses. What lies in between those is something that we call arguments or parameters to the method. We will be talking about that and all these concepts repeatedly throughout the semester. For now, just kind of take it as it comes. Most of what I'm doing this week and next week will be sort of copyable for the sake of being able to do your own work. You don't need to understand all of the elements that go into this in order to be able to produce the assignments. And as you go through the entire semester, you will get to a place where each of these elements is something you truly understand and could then explain to someone else. We start by working on what I call faith, and then we build the understanding from that through doing and through seeing the various examples. So inside the main method, we are going to put in one line of code. I'm going to put in system.out.println. The print ln is pronounced print line. I'm going to have my opening and closing parentheses and the opening and closing quotes. And in there, I'm going to type in hello world. This message or string is what will be displayed by this program when it is run. You'll notice the periods in between certain words, and you'll also have noticed that I pronounce those as dot. System.out.println. System is another class, much like the one we're writing called hello, that exists as part of the Java language environment. Out is a particular object. We'll be learning more about objects in the second half of the class. That it contains within itself a method called println. Println is a method similar to main being a method. The argument that we send, the parameter that we send to that method, is this message. Any text in between double quotes like this is called a string. We'll be learning a lot more about that again throughout the semester. For now, just know that we're sending this message to this method so that it can print it out to the screen. At this point, we are through with our first program. You'll see that it is 7 lines of code and very simple. A lot of what you're looking at you can think of as a template. The public class with some name, the public static void main, string args is something that you'll be using repeatedly throughout the semester. And then we have a single command. This line inside the main method is, for all intents and purposes, the only thing that is actually executed in running this program. This is the only command that does something. The rest of it is a template or boilerplate that sets things up so that the compiler and the runtime environment know how to work with your code. So we'll save our work. I will be saving all my work to my personal drive, and I will upload every example you see in these videos to the Canvas course shell, and I will show you where that is before the end of this particular video. So we will go into our example subdirectory for this class. One thing that's very important when working with Java is that the name of the file name must match the class name. Java is what we call a case-sensitive programming language, so case does matter. We generally, by convention, create our class names beginning with a capital letter and using lowercase letters past that. If for some reason, and we will see examples of that this semester, there's more than one word, we do not separate by spaces but use capital letters to begin each new word and put it together all as if it were one word. We'll talk more about that as we proceed. Every source code file in Java will have a .java extension. So hello is the name of the file, .java is the type of the file. That is a Java source code file. So I will save that. And now that we have the source code, we need to get to a place where we can run that source code. One of the things that makes Java unique among major popular programming languages is that it is what we call an interpreted language. Java was invented by some engineers at Sun Microsystems, a company that was eventually absorbed by Oracle. And it was designed specifically so that the runnable program would be very portable. One of the problems that the engineers were trying to solve was being able to write programs and compile them once, but allow them to be used on a wide variety of systems. It's one of the reasons that it's maintained its popularity is that programs created in Java can be used on various kinds of systems, PCs, Macs, various phones, um, devices that have embedded chipsets in them, uh, and things like that. And the idea that they called write once, run anywhere was sort of one of the foundational pieces. We'll be seeing that, looking at it, and talking about it again throughout this semester. So in order to get the program to a runnable state, we have to compile it. Compiling in computer science is the process of turning source code into something that the computer can understand. At this point, most of you certainly have heard that the computer speaks ones and zeros, or binary language, sort of a language of ons and offs, the presence of an electrical signal or the absence of an electrical signal. That's very hard for the human brain to understand, so we've all created these higher level programming languages that allow us to do something that's logical and repeatable, but also easy to translate into the ones and zeros that the computer speaks. So turning our source code into that binary is a process called compiling. In Java, the name of the compiler is Java-C, which stands for Java Compiler. We pass or feed that compiler the program which we wrote, which is in this case hello.java. So Java-C invokes the Java compiler. Hello.java is the file, the source code we want to invoke it with. When we hit return, we'll see that it pauses for a minute while it does the compilation, and then the prompt comes back. If you receive no messages between the two prompts when compiling, that means that the file compiled successfully. If I do a dir or directory command, you'll see that there's both the original source code hello.java file, and there's also now a new file called hello.class. This hello.class is the file, the translation of the source code into something the computer can understand. In Java specifically, the binary code is understood by a non-existent machine called a virtual machine. The way that the engineers design the language to be most portable is they allow for other developers to create a program called a virtual machine that sort of mocks a program that understands Java binaries, the same on all systems. The benefit of doing the virtual machine is that the .class is compiled for a Java virtual machine regardless of the underlying architecture of the computer it's running on. Whether your computer was or is a Spark station, a piece of hardware that Sun Microsystems used to put out, or a Windows-based PC, or an Android phone, the class is essentially intended to be able to run on all those platforms through the virtual machine without having to rewrite or recompile anything. This particular binary has a special name in Java. It's called a bytecode file. And the bytecode is what runs inside of the Java virtual machine. How we do that is we invoke the virtual machine by using the command Java, and we send it the name of our class file. We do not put .class after the file name when invoking the virtual machine. It is understood that the file that's being fed to it is a .class file, and if you type in the .class, what you will see is that that produces an error. It says it could not find or load main class hello.class. The reason that is in this case is it's actually looking for hello.class.class. So if we just do Java hello, what will happen is the bytecode or translated version of our source code will be run through the virtual machine that sits on top of this computer environment, and it's run in that way and will produce the results. So when I hit return, you see that my message appears on the console, and then we get our prompt back. The program worked as advertised. I'm going to add just a couple of extra pieces to this program at this time. I'm going to begin it with something called a comment, a block comment that describes what this source code is and does. I'm going to say this is a minimal program written in the Java programming language for the purpose of demonstrating Java basics to new Java programmers. The important parts of this comment in terms of the grammar or syntax of the program is the /star, which tells the compiler that what's coming up is to be ignored. It's not commands to be executed, but text to be read by anyone looking at the source code. And the // which lets the compiler know the block comment is complete. So this entire set of typing or of code in here is to be ignored by the compiler and is only viewed by people who are reading the source code. These are comments that allow other people to understand what your code is. Every example that I create in this class will have a large number of comments. Those comments are intended to allow you to review the code that I've written and understand it more thoroughly. There is a second kind of comment that we'll be using in this class called a line comment. It is indicated by 2 slashes and tells the compiler to ignore anything on the same line after the / up until you hit the enter or return key on the keyboard. So what I'm going to do here is I'm going to indicate that every Java source code file will contain a block of code called a class. Again, we'll understand more about what a class is in the future. I can add these line comments after interpreted code, like the public class hello, because it only starts to ignore starting at the beginning of the line comment until the end of the line. I'll say that this class is called hello. Go back up here. I'm going to add a second line comment that says the public class hello code is the header of the class block. The open bracket begins the code that defines the class block, comma, and the close bracket ends the code that defines the class block. Now, once you've seen a couple of examples and programmed a little bit yourself, you're not going to need all this in-depth explanation for your class header. But again, this is our first program, so I am going to give you all these extra details just to help you try to understand what these things are and what they mean. Whoops. So here, I'm going to put another line comment that says the set of code to be run or executed in this class is contained in a special code block called a method. This method is called main. The string args code inside the parentheses are the arguments or parameters expected by this method. Again, there will be more on that later. For this time, we just need to know that public static void main, open parenthesis, string, square brackets, args, close parenthesis, will be the name of the method that we run all of our code inside of. You'll become very familiar with this. You'll repeat it in every program that you write throughout this, this course. We again have our open bracket for the defined block, and now we have the one executed line of code. The following line is a statement that will be executed inside the Java virtual machine. Whoops. System.out.println is a special command that displays messages to the computer screen. Println is a method, comma, and words in double quotes is the argument being sent to it for display. So again, println is a method that takes in this message something called a string that we'll learn more about later, and it displays it on the screen. System.out, which we're calling the method for, that's simply a reference in code to the regular console screen of the system on which you're running the application. I'm going to put a piece of code here that says end of main method, and another line one here that says end of hello class. Just as a means to let you know what everything is. So hopefully this set of comments will be enough for you to understand the basics of creating a program. From this, by simply changing out the words hello world with something else, you'll have the ability and the opportunity to create programs that print out any message that you might want to do. Obviously, this will be something we'll be doing a lot of, because displaying the output for the person using your program is an indispensable kind of feedback for any useful piece of software. Now you'll notice that the commenting part of the code is about twice as large as the actual executable or run code. That is not typical in the professional world, but since we're just learning now, adding all these extra comments gives you the ability to understand, or at least follow, what it is you're seeing in a runnable program, so that you can mimic that in your own development when you do your own homework and test assignments. Going to resave my work. Now, for my own personal benefit, I am going to recompile the program, because even though all the changes I made were comments that should not affect the way the program runs, there's always the possibility that I or anyone could make a mistake. So recompiling the source code allows me to make sure that I didn't make any mistakes. We'll then run the Java program using the Java virtual machine invocation and the name of the class file. And it still produces the same message for you. As I said before, every time I create a new program, I will post it to our course shell, the CIT 130-1002 course shell, and it will be under Files over here, as well as you'll be able to see it from the examples page. The reason I use an examples page is it allows me to indicate the date of the week this example goes with, or what lecture it goes with, and to tell you what it does to jog your memory when you're inside here. So what I'm going to do is I am going to upload this file that we just created. From my drive. And I'm only uploading the source file so that you have the ability to open it up in your own text editor or IDE. The source code is all you really need in order to be able to see what we did and to play with that for your own benefit. I'm going to put here a simple description. This is the most simple Java program, comma, that simply displays a message to the screen. And I'm going to mark it as Lecture 1. Since this is an online course, I'm not going to use dates. I'm going to simply just put which lecture the example goes with. And this lecture will be, you'll be watching that from the YouTube channel, so that when you go into the Canvas shell, you'll be able to see from there the example that we programmed here. You will be able to download that, and you will be able to play with it, modify it, and use it in whatever way that you need to. So this concludes the first lecture. It gives you the simple beginning information you need. Next week there will be a second longer lecture uploaded that's going to go through in much more detail on the types of elements that we put into a Java program. We'll look at simple examples of those elements for use in our own development. After that second lecture, the first homework assignment will be available for you to practice these concepts on your own. I hope you learned something and that you enjoyed this today, and I look forward to next time. Take care.